My name is Dr. Michael J. Krashes. We're in the National Institute of Health Clinical Building, Building 10. And I've been at the NIH now for just over a year. Our main culprit is probably obesity and feeding-related disorders. And what we do in the lab typically is we go after the neural circuits or the actual cells in the brain called neurons, and we try to figure out which ones of those, which has groups of those neurons, actually influence changes in appetite. So I'm from just outside of Boston, and I actually was there throughout my entire life. I did my undergrad, my grad work, and my postdoc all in the Boston area. And so this past year has been the first time I've ever moved. And my mother was a chemist, so that's what led me into the world of science, both scientifically and through her work ethic has really kind of pushed me in the direction that I've taken. I always wanted to be a medical doctor. Even after I graduated college, I still really wanted to go that way. And then I started working in a laboratory for the first time, and it really piqued my interest in pursuing this career. So right now we're at a stage where about 5 years ago we really identified a group of neurons that we can just turn on and off like you would imagine turning on and off a light switch. And you turn these neurons on and it just causes the animal to eat until it just cannot eat anymore. And I think that was really the turning point in our field of feeding, because it really showed that there are just specific neurons, specific cells in the brain that can control such a stereotyped behavior. What we're looking at here are specific subsets of neurons in a part of the hypothalamus that regulate feeding behavior. And this specific group of neurons, if you're able to just turn them on like a light switch, they will cause the animal to go and seek out and eat food. So to really tie in how those neural circuits are all related to one another is really the future of where this field is going. We like to bring the brain tissue back into the lab, and what we'll do is we'll actually slice the brain tissue with a microtome so that we can actually cut it up into thin slices, so then we can then place that on slides and then investigate our circuits using microscopy. So you can imagine you go through the entire brain. This takes about an hour. So pretty time consuming, but worth it in the end, because this is what we then mount on those microscope slides so that we can then look at it under the microscopes. Obesity is this huge epidemic, especially in well-developed countries like the United States. So having a better understanding of how the brain actually controls eating will help to lead to therapeutic, targets of drugs that can actually have an effect and fight the war on obesity. It's very collaborative, the work that we do here, both within the NIH and outside. We have collaborators within our branch, as well as collaborators outside the institution.
Okay.
So yesterday you photostimulated the AGRP
In the first
without
hour,
light.
they ate maybe 0.01 gram.
Okay, so very little. So I would say that we'll do that experiment one more time. I was thinking tomorrow, but now that I'm thinking about it, I really want you to do it, just because I want you to experience it. So maybe we'll just do it first thing on Friday morning.
Yeah.
And then repeat that. We want to do the appetitive reinforcement of feeding in the hungry state. So during the conditioning phase, and then at the testing phase, we'll then photostimulate AGRP neurons and try to mimic that hunger effect. The way that we can actually go inside and really control specific molecularly circumscribed discrete neurons, and how we can just, again, turn them on and off with different techniques is really puts us at the forefront of neuroscience. And we have all the opportunities to do so here at the NIH. Don't be completely set with one path, because I feel like as life progresses, you experience all new types of experiences, and something will really pique your interest and set you on the right path.